For almost 100 years, one material has been hiding inside the walls of your home. You have probably touched it. You have almost certainly breathed in tiny pieces of it. Fiberglass, pink, itchy, cheap, and absolutely everywhere. It insulated the houses your grandparents built, the ones your parents bought, and very likely the room you are sitting in right now. And for the longest time, nothing was ever supposed to replace it. It was simply too cheap to beat. Then something shifted. Across dozens of factories in China, a very different material started rolling off production lines by the ton. A material that is more than 90% air. A material that insulates nearly 3 times better than fiberglass, yet can be sliced thinner than a coin. For decades, the entire world dismissed this stuff as a laboratory curiosity, a beautiful science fair trick that was far too expensive to ever matter in the real world. China looked at that problem and did what China does best. It made the impossible so cheap, and right now, quietly, the global insulation industry is starting to worry. Before we get into how a material once reserved for spacecraft ended up threatening a 90-year-old industry, do one small thing for me. If you enjoy stories about the technologies quietly reshaping the modern world, hit that subscribe button. It genuinely helps these deep dives reach more people who would find them fascinating, and there is a brand new one every single week. Alright, let's get into it. To understand why this is such a big deal, you first have to understand just how deeply fiberglass is woven into modern life. Back in the 1930s, an engineer named James Slater was working at a glass company in Ohio. The story goes that a jet of compressed air accidentally hit a stream of molten glass, and instead of forming a solid pane, the glass exploded into a cloud of impossibly thin fibers. Those fibers trapped pockets of air, and trapped air, it turns out, is one of the best insulators nature ever gave us. That accident became an industry. By the middle of the 20th century, fiberglass was the default way to keep heat inside a building in winter and outside in summer. It was light, it was fireproof, it was made from sand, one of the most abundant materials on the planet, which meant it was almost unbelievably cheap. Roll after roll of that fluffy pink material got stuffed into the walls, attics, and floors of hundreds of millions of homes. If you have ever renovated a house and pulled out a section of wall, you have met it. And if you did that without gloves, you remember exactly how it felt. Because here is the dirty secret of the material that keeps us comfortable. Fiberglass is an irritant. Those microscopic glass fibers break off, float into the air, and lodge in your skin, your eyes, and your lungs. Anyone who has installed it knows the itch that lasts for days. Construction workers wear masks and full-body suits to handle it, and over the years, questions kept surfacing about what breathing that dust really does to the people who work with it every day. The industry insisted it was safe when handled properly, but nobody was ever comfortable calling it pleasant. There was another problem, one that became more serious as the decades passed. Fiberglass is bulky. To get a genuinely warm, energy-efficient wall, you need thick layers of the stuff. In an old house with narrow wall cavities, there simply is not enough room to pack in the performance you need. As energy prices climbed and governments started demanding better efficiency, that bulkiness turned from a minor annoyance into a real engineering wall. You cannot make a wall thicker than the wall. Builders were hitting the physical limits of what fiberglass could ever do, and yet, decade after decade, nothing dethroned it. Not because better materials did not exist, several did, but every one of them ran into the same brutal fact. Fiberglass was so ridiculously cheap that any challenger had to be not just better, but better while also being nearly free. That is an almost impossible bar to clear. Rigid foam boards existed, but they cost more and came with their own fire and chemical concerns. Mineral wool existed, denser and more fire-resistant, but heavier and pricier. Every alternative could beat fiberglass on some single measure, then lose the war on cost. So, the pink stuff reigned, unloved but unbeaten. the undisputed king, purely because it was the cheapest way to fill a wall with trapped air. So for decades, scientists dreamed of something better. And it turned out that something better had already been invented. It had just been sitting on a shelf, quietly, for almost a century. The story goes back to 1931. A chemist named Samuel Kistler made a bet with a colleague. The challenge was to remove all the liquid from a jelly without letting the jelly collapse. It sounds simple. It is not. When you dry a gel the normal way, the liquid evaporating out drags the delicate internal structure down with it, and the whole thing shrinks into a hard little lump. Kistler figured out a way to swap the liquid for gas so gently that the internal skeleton stayed standing. What he was left with was astonishing. A solid that was almost entirely empty space. A lattice of silica holding up nothing but air. He called it Aerogel. Other people started calling it frozen smoke, because that is exactly what it looks like. Hold a piece up to the light and it glows a faint, ghostly blue, like a puff of solid fog you could balance on your fingertip. It is one of the lightest, solid materials ever created, and crucially, it is the single best insulator that human beings have ever made. All those millions of tiny pockets of trapped air, sealed inside a structure so fine that heat literally struggles to find a path through it, make aerogel almost supernaturally good at stopping the flow of temperature. To really grasp why it works, picture how heat actually moves. Heat travels by riding through solid material, and it travels by letting air swirl and carry it along. Most insulation only fights one of those battles. Aerogel fights both at once. There is barely any solid for heat to conduct through, since the material is almost all air. And the air itself is trapped in pockets so tiny that it cannot swirl or circulate to carry heat across. Heat arrives at one side of a sheet of aerogel and essentially gets lost in a maze with no exit. That is why a layer you could nearly see through can hold back temperatures that would roar straight through ordinary insulation. For a while, it looked like the future. And then, for about 60 years, almost nothing happened. The problem was money. That gentle drying process Kistler invented required extreme conditions, enormous pressure, careful chemistry, and a great deal of time. Making even a small block of aerogel was slow, delicate, and wildly expensive. It was the kind of material you could produce in a laboratory for a research paper, not something you could ever imagine stuffing into the walls of an ordinary house. So, aerogel became a specialist toy. It insulated scientific instruments. It showed up in museums as a curiosity. People marveled at it and then walked away, because there was no way to make enough of it at a price anyone could actually afford. Its big early break came from space. When agencies needed to protect delicate equipment from the brutal cold and heat of the void, aerogel was perfect. It was light, which matters enormously when every kilogram costs a fortune to launch. It was an incredible insulator, which is exactly what you need when the temperature outside swings by hundreds of degrees. Aerogel rode along on missions to capture comet dust and to keep rovers warm on other worlds. But that only reinforced its reputation. This was exotic stuff, the material of billion-dollar programs, not something for the person renovating their kitchen. The first real attempts to commercialize it did not arrive until the early 2000s. A handful of Western companies opened the first true manufacturing plants. One started production in Germany around 2003. Another opened a plant in the United States around 2008. They found genuine markets, especially insulating oil and gas pipelines, where space is tight and performance matters far more than cost. Deep under the ocean, wrapping a pipe carrying hot crude oil, you cannot afford bulky insulation, and you cannot afford heat loss either. Aerogel was ideal. For those niche, high-value jobs, it made perfect sense. But for the mass market, the everyday world of walls and roofs and ordinary buildings, it remained a distant dream. It performed like a miracle, and it was priced like one too. And that is where the story would have ended. A brilliant material, admired by everyone, used by almost no one. Except a new player was about to enter the field, and this player did not think about aerogel the way everyone else did. Where the West saw a premium specialty product to be sold carefully at a high margin, China saw a manufacturing problem to be solved at massive scale. And solving manufacturing problems at massive scale is a game China has been winning for 20 years straight. To understand what happened next, you have to understand the pattern. Think about what happened with solar panels. For years, they were a luxury, an expensive statement for wealthy homeowners and government demonstration projects. Then Chinese manufacturers poured in, built factories of staggering size, refined every step of the process, and drove the price down so far that solar became the cheapest form of electricity in much of the world. The same story played out with lithium batteries. The same story played out with electric vehicles, with LED lighting, with drones. The strategy is almost always identical. Take a technology that already works but is too expensive, and grind the cost down through relentless scale and engineering until it becomes ordinary. Aerogel was a perfect target. The science was already proven. Nobody needed to invent it. The only thing standing between aerogel and the world was cost. And cost is precisely the wall that Chinese industrial policy is built to smash through. The push did not come out of nowhere. It was driven by a very specific and very modern need: electric vehicles. Inside every electric vehicle battery pack sits a genuine danger. If one cell overheats and fails, it can trigger a chain reaction in the cells packed next to it. A runaway cascade of heat that can turn a battery into a fire that is almost impossible to put out. This phenomenon has a name that engineers say with real fear: thermal runaway. Once it starts, it feeds on itself, cell after cell, and the result can be catastrophic. Car makers have watched competitors suffer recalls, fires, and shattered reputations over exactly this problem. So, engineers desperately needed a material to place between those cells, something thin, because space inside a battery pack is precious, and every millimeter you waste is range you lose. Something light, because weight is the enemy of an electric car, and something that could stop a wave of extreme heat dead in its tracks, buying precious seconds for the system to react before the fire could spread. Aerogel was almost tailor-made for the job. A wafer of it, thinner than a few sheets of paper, could sit between the cells and hold back a blast of heat that would otherwise leap from one to the next. As China became the largest maker of electric vehicles on Earth, its demand for these thin aerogel heat barriers exploded. Suddenly, there was a gigantic, guaranteed domestic market for the material, not in tiny research quantities but in industrial volumes, growing every year. And that changed everything. Once you are building factories to churn out aerogel by the ton for millions of car batteries, the economics transform completely. The same production lines, the same refined chemistry, and the same falling costs that serve the battery market can also serve buildings, pipelines, and clothing. The battery boom paid for the factories, and the factories made everything else cheap. Company after company sprang up across China's coastal industrial zones. Firms in Zhejiang, in Guangdong, in Shenzhen, and beyond. Some of them now run production lines capable of turning out over 1,000 tons of aerogel powder a year, each. One of these companies became the principal author of China's first national standard for the material, a quiet but telling sign. When a country starts writing the rulebook for an industry, it is signaling that it fully intends to dominate that industry. These were not small research outfits chasing grants. These were serious manufacturers building serious capacity, and they were locked in fierce competition with one another to produce more, faster, and cheaper than the factory down the road. That competition is the engine. When dozens of companies fight for the same market, they are forced to cut costs, improve their processes, and slash their prices just to survive. Industry watchers in China have openly described aerogel prices falling year after year, with the drop accelerating as production scaled and as the material started reaching ordinary buyers instead of just big industrial clients. Some producers have even started marketing to everyday customers, selling blankets and panels by the roll to anyone who wants them. A material that was once so precious it felt almost sacred is now being shipped out in bulk pallets. The frozen smoke came down to earth. So how did China actually pull this off? How do you take a material famous for being expensive and make it affordable? The answer is a grind of 1,000 small improvements, rather than one single magic breakthrough. Chinese labs and factories attacked every stage of the process at once. They found cheaper starting chemicals to build the silica skeleton, tapping into the country's vast chemical industry instead of relying on costly imported ingredients. They refined the delicate drying step, the single most expensive part of the whole operation, squeezing out time, energy, and danger. Some pushed toward methods that need less extreme pressure, which means cheaper equipment and safer plants. And critically, they moved away from making aerogel in slow, one-off batches toward something closer to a continuous flow, where material moves through the process without ever stopping. Every one of those changes shaved a little off the price. Stack enough of them together, across enough competing factories, and a luxury material slowly turns into a commodity. It helps to remember just how enormous the prize really is. Insulation is one of those invisible industries that almost nobody thinks about, yet it is worth many tens of billions of dollars every year worldwide, wrapped inside nearly every structure that human beings build. Fiberglass has owned the biggest, cheapest slice of that market for generations. So when a new material starts peeling away even a fraction of it, the numbers involved are staggering. This is not a fight over some tiny specialty product tucked away in a corner. It is a slow-motion battle for a foundational piece of the global economy. And the companies who have ruled it for decades know exactly what is at stake. So let's talk about what this material actually does, because the numbers are the whole reason the insulation industry is nervous. Remember, the goal of insulation is to stop heat from moving. Engineers measure how easily heat passes through a material, and the lower that number, the better the insulator. Ordinary fiberglass sits at a fairly modest level. Aerogel comes in at roughly a third of that value, sometimes even less. In plain terms, a layer of aerogel can do the same insulating job as a much thicker layer of fiberglass. We are talking about matching the performance of a fat, bulky bat of pink insulation with a thin blanket you could roll up and carry under one arm. Think about what that unlocks. In an old building with thin walls, where there was never enough room for proper fiberglass insulation, you can now line the interior with a thin aerogel layer and suddenly hit modern efficiency targets without losing precious floor space. In a factory, you can wrap scalding hot pipes with a slim jacket instead of a thick, awkward casing. In a jacket or a pair of boots, a wafer of aerogel can keep a person warm in brutal cold without the bulk of traditional padding. Explorers heading to the poles have used it. Firefighters and industrial workers rely on aerogel to survive heat that would kill them in ordinary gear. The material's superpower is not just that it insulates better. It is that it does so while taking up a fraction of the space. And in a crowded, expensive, space-hungry modern world, space is everything. You can already see the early edges of this shift in the real world. In cold northern climates, aerogel blankets are being used to retrofit old stone and brick buildings that could never be properly insulated before. Buildings where adding thick modern insulation on the inside would have swallowed entire rooms. Cold storage warehouses use it to keep freezers efficient without walls a meter thick. Outdoor clothing brands have quietly built thin aerogel layers into jackets and gloves for people who work or climb in extreme cold. It is turning up in shipping containers, in spacecraft, in the pipes of chemical plants, and in the battery packs of the cars filling Chinese streets. None of these are dramatic headlines on their own, but together, they trace the outline of a material spreading out from its expensive little niche into ordinary daily life. There is more. Good aerogel does not itch and shed sharp fibers the way fiberglass does. Many versions are engineered to repel water, which matters enormously because wet insulation is useless insulation and can lead to mold and rot inside a wall. It handles high temperatures that would degrade or melt other materials. It is remarkably light, point by point. On almost every measure that engineers care about, It beats the pink stuff that has ruled the walls of the world for the better part of a century. The only category where fiberglass ever truly won was price. And that was the exact wall China set out to demolish. And there is the human side of all this, the part that rarely makes it into a spec sheet. For the workers who spend their lives installing insulation, the difference between a material that sheds sharp glass fibers and one that does not is not an abstraction. It is the itch, the cough, the protective suits, the years of exposure to airborne dust. A cleaner, safer material to handle is its own quiet revolution for the people whose hands actually build our homes. And at the far end of a building's life, when it is finally torn down, the question of what happens to all that old insulation matters too. The choices we make about what fills our walls echo for decades, long after the builders have packed up and gone home. Now, this is the part where honesty matters, because a good story should never lie to you. Fiberglass is not actually dead, not yet, and maybe not for a long time. Even with Chinese production driving prices down dramatically, Aerogel is still meaningfully more expensive than fiberglass for a basic wall. Fiberglass is so absurdly cheap, so easy to make from sand, and so deeply embedded in construction supply chains all over the planet that ripping it out overnight is simply not going to happen. When you just need to fill a big empty wall cavity in a new house and cost is the only thing that matters, plain fiberglass is often still the sensible choice. So the headline that China killed fiberglass is, strictly speaking, an exaggeration. Aerogel has its own weaknesses too, and it is only fair to name them. In its purest form, it can be fragile and crumbly, prone to shedding a fine dust when handled, which is why most real products blend it into flexible blankets and composites to hold it together. Making it still involves careful chemistry and specialized equipment, so even at scale it will probably never be quite as dirt cheap as melted sand. And any brand new material has to earn decades of trust before builders bet millions of dollars and entire buildings on it. These are real hurdles. The pink champion is not going down without a fight. But here is why the exaggeration still points at something very real. Technologies do not usually die in a single dramatic moment. They die slowly, from the edges inward. Aerogel does not need to replace fiberglass in every single wall to reshape the industry. It only needs to win the places where fiberglass was always weakest, the retrofits where space is tight, the high-performance buildings chasing strict energy codes. The industrial jobs, the electric vehicles, the cold weather gear, the pipelines, the ships. Every one of those is a market where the thin, superior newcomer wins, and every one of those markets is a chunk quietly carved away from the old champion. And as production scales further and prices keep falling, that circle of places where Aerogel wins keeps getting wider and wider. That is the pattern that should sound familiar, because we have watched it happen again and again. A superior technology sits on the shelf for years, held back only by cost. Then someone finally cracks the manufacturing. The price collapses, and what was once a luxury quietly becomes the new normal. Nobody wakes up one morning and announces that the old thing is finished. It just slowly stops being the obvious choice, until one day you look around and realize the world has already moved on without you. That is how fiberglass most likely fades, not with a bang, but with 1,000 small defeats, one market at a time. And it raises an uncomfortable question for the West. The core science of aerogel was Western. It was invented in an American laboratory in 1931. The first commercial plants were Western. Western companies still make excellent, advanced aerogel products, and the biggest single player in the high-end battery market is still an American firm selling hundreds of millions of dollars of the stuff. But when it comes to sheer manufacturing volume, to driving the price down to the point where a material can flood into everyday use, China has seized the initiative. The same playbook that gave it dominance in solar panels and batteries is now being run on the humble world of insulation. Invent it there, perfect the factory here, own the future. There is a strategic edge to this that goes beyond warm homes. Insulation is not glamorous, but it is foundational. Whoever controls the cheap, high-performance material materials of the future controls a piece of every building, every electric car, every pipeline, and every power plant that gets constructed. Countries that depend on imported insulation for their most advanced batteries and buildings are quietly handing another lever of their economy to a supplier on the far side of the world. It is the same uneasy realization that arrived with solar panels and batteries, arriving again in a form almost nobody is paying attention to. The material in the walls has become a matter of national strategy. None of this means panic is the right response. It simply means paying attention. The quiet materials, the boring ones hidden inside walls and battery packs and pipelines, are often the ones that quietly decide who leads and who follows in the century ahead. We tend to notice the flashy inventions, the robots and the rockets and the glowing screens. But the real foundations of modern life are humbler than that, and control over them shifts slowly, almost invisibly, until one day the map of who makes what has been completely redrawn while nobody was looking. For ordinary people, though, the outcome is genuinely good. Better insulation means homes that are cheaper to heat and cool, which means lower bills and less energy wasted. Buildings account for an enormous share of global energy use, and a huge portion of that energy simply leaks out through poorly insulated walls and roofs. A cheap, thin, high-performance insulator that almost anyone can install is exactly the kind of unglamorous technology that quietly fights climate change without anyone marching in the streets about it. If the frozen smoke really does spread into the walls of the world, all of us benefit from it, whether we ever learn its name or not. But it is also a story about power, about who gets to control the materials that build the modern world. 100 years ago, an accident in an Ohio glass factory gave us the pink stuff in our walls. 90 years ago, a chemist won a bet and created a solid made of air, then watched the world shrug and walk away. And now, in the factories of coastal China, those two threads are finally colliding. The specialty material that everyone admired but nobody could afford is being turned into something ordinary, and the cheap, itchy champion that ruled for a century is, slowly and quietly, being backed into a corner it may never escape. So what happens over the next several years? If the pattern holds, and it almost always does, aerogel prices keep sliding while its performance keeps improving. The gap between the frozen smoke and the pink fluff narrows, and then, in more and more situations, it disappears entirely. Building codes around the world keep tightening, demanding walls that leak less heat with every passing year, and those stricter rules play directly to aerogel's strengths. A thin material that hits high performance inside a slim wall is exactly what a stricter future is asking for. Meanwhile, the electric vehicle boom keeps pumping money and scale into the factories, driving costs down even further for everyone else. The forces here are all pushing in the same direction, not toward a sudden overthrow, but toward a steady, grinding, almost quiet takeover. So the next time you are in an old house, and you catch a glimpse of that familiar pink fluff behind a wall, take a good long look. You may be looking at the end of an era, not a sudden death, but a long, slow handover, engineered thousands of miles away, one falling price at a time. The material that kept us warm for 100 years is not being defeated in a single dramatic blow. It is being quietly, patiently, priced out of existence, and most of us will never even notice the exact moment it happens. If this was interesting, there is a whole world of stories just like it, technologies you have never heard of that are quietly deciding what the next few decades will look like. Subscribe right now, and I will see you again in the very next one.